next question on the menu. So the next question is, what is the derivative of absolute value functions? Well, first, let's talk about what even is an absolute value function. You might see them, typically you're going to see them as vertical bars like this, so like x. Or sometimes you might see them like this, like abs. Typically like this. What this means is that if negative, make positive. If positive, keep positive. It's basically just saying, if you're negative, we're going to multiply you by -1. If you're positive, you're good. Sounds good? All right, so let's say we have a relationship. Let's say we have it like y equals the absolute value of x. Let's think about what this would look like graphically. So we have our x-axis here, our y-axis here. Let's call this like 1, 1, -1. Okay, so let's start at 0. Like when x is equal to 0, y is equal to 0. Sounds about right. When x is equal to 1, y is also equal to 1. Looks reasonable. And if x is equal to 2, y should also be equal to 2. So far, so good. Now, remember what we said earlier. If negative, make positive. So let's say x is equal to -1. We got to make it positive. So it's going to be, when x is equal to -1, y is equal to +1. Y being the output of the function. Let's say we have x equals -2. In the same way, y is going to be equal to +2. Because the input is negative, the absolute value says if it's negative, positivify. Make it positive. Yeah. So basically we're going to get a function that kind of looks like this. Let's say we have like, I'll do a different color for this, maybe red, like strawberries. Y is equal to 3x. Well, if y equals 1, if x equals 1, y equals 3 times 1, that would be 3. And if y equals -1, if x equals -1, y is 3 times -1, but those are inside the absolute value, so that would be +3 as well. So like, no matter which way you flip it, somehow, some way, these absolute functions, absolute value functions, they kind of got like, this, like they're really excited and trying to show you something big type of expression. Like they're doing the YMCA-Y. All right, so how do we find the derivative? Well, we know the derivative is what's tangent to it. And with these, they are like mostly straight lines. So we should expect that their derivatives should be fairly constant. Except that, it depends on like if you're going down or going up. But otherwise, since the line is straight, the tangent line is always going to have the same slope. So we should expect a constant value for the result of our derivative. Okay, cool. So now that we have our some basic fundamental knowledge about absolute value, let's pull out our equation. Equation for value differentiation. Okay, now let's say f of x is within these bars here. Like f of x, it could be x by itself. In this other example, we have 3x. You could have pretty complex functions in here. You could even have like multiple functions. But let's just like pretend that is 1 for now. So the derivative of this, d over dx of absolute value, f of x in the absolute value, is equal to the inside on the top, f of x, divided by the inside on the bottom, but that remains in the absolute value. All of this is multiplied by the derivative of the inside. Sounds good? This is our formula for the derivative of absolute value. Keep that handy. Okay, so let's say we have an example. Let's say our most basic example, we have y equals absolute value of just x on its own. Well, following the formula here, we're going to take the inside, just naturally, put it on top of the fraction, x right there. We're going to take the absolute value of what's on the bottom. Oops, let's make that bar a little more straight so that it's clear that we're talking about absolute value here. And we got to multiply it by the derivative of what's inside. So here, we just have x on the inside. The derivative of that is 1. So we just multiply it by 1. And that's about it. So let's see what this means. For x is greater than 0, this is just going to be y prime equals 1. Right? Remember our graph, it was like y, x, it looked like that. When x is greater than 0 and we're on this side, the derivative is 1, meaning that the slope is a constant 1. That looks pretty reasonable. Now let's see when x is less than 0. When x is less than 0, let's say x is like negative 1. Well, we'll sub that into our equation. Negative 1 divided by the absolute value of negative 1, that's positive 1. So it'll be negative 1 divided by positive 1. Regardless, you're going to have like the x on the top and the x on the bottom, they're going to divide each other out, but their signs are going to be opposite when we have x less than 0. Because of that, the answer to the derivative of this when x is less than 0 is that it's always going down with the slope of negative 1. Equals negative 1 when we're on this side. Looks about reasonable. Now, let's talk about the super special case when we have x equals 0. When x equals to 0, we're basically trying to do 0 divided by 0. Ooh, that divided by 0, that's an issue. That's something you definitely do not want to be doing. So you can't really find the derivative there. Also think about this way, like it's a corner, like this, at the base where x is equal to 0. Because of that corner, like what's the tangent line? Like originally it was like this, and then it's doing here, like it's trying to be both at the same time. It doesn't work out. So just know that there are certain places like corners, sometimes vertical lines are also like this, where it is impossible to actually find a derivative at certain points. Okay? So keep that in mind. This would be like basically your output for the function of absolute value of x. Let's run through another example where we have something a little bit more spicy inside. So like the example that we had previously is like, example, y is equal to the absolute value of 3 times x. All of that's an absolute value. We're going to run this through our equation here. So we have y prime equals to 3x divided by the the absolute value of what was inside. And then we have to multiply this whole thing by the internal derivative of the absolute value. So inside we have 3x, the derivative of that is 3. So the 3 here and the 3 here cancel out. So we get x over absolute value of x, 3x. Just moving the 3 here to the front. Okay. Now let's do a similar type of analysis that we did for the previous one. For x is bigger than 0, x less than 0, x equals 0. X equals 0, we're still going to have the same thing. I guess it would be, you'd write it as not exist. The backwards E stands for exist. Sending a line through it means not exist. If x is bigger than 3, we would have just like no absolute value. Like we would put in something for the x at the bottom here and it would end up being positive. So that would divide out and we would just have 3 prime equals 3. If x is less than 0, meaning that x is negative, we will have this will become negative x because we have to like undo the negation in the bottom because of the absolute value. And then we will have like a negative value up here divided by its positive version of itself. The magnitudes divide out, but there's still going to be a negative on the bottom. Negative on the top. So the result of that is going to be y prime equals negative 3. Now if we scroll up to our little diagram that we had of this, y equals 3x, we can see that makes perfect sense. Like the slope is a little bigger here for the red line where it's 3x. It follows the same pattern, and all in all, I would say that we definitely have found our answer. So the key here is that the derivative of your absolute value is going to be this equation. Keep this equation nice and handy. Because if you ever get asked, hey, what's the derivative of this absolute value function? You're going to know exactly how to deal with it if you got this in the bag. All right. Sounds good. All right. So I can just got to verify the solution. Solution is good because yes, maybe I'll just say above solution is showing the chain rule. That's the reason why we're multiplying the inner derivative, is because the chain rule. Okay, so just gonna clean up the whiteboard and then we can move on.